Welcome to the specific heat capacity tutorial. This is a tutorial taking you through the steps you need to find out how much heat is needed to increase the temperature of your particular substance. In this case, the original case, we're going to be using some strips of metal that I've given you. Step one is to find the mass of 3 or 4 pieces of your metal strips. You want the metal to be pieces small enough that they will fit comfortably into a graduated cylinder, probably the same pieces you used to find density, but make sure they're dry before you get their mass. So put your 3 or 4 pieces onto your balance and get the mass. You have to use a triple beam balance for this whole experiment, but for this one part of it, you could use the electronic balance. The reason we're going to use the triple beam balance later is because we're going to start using masses more than 100 grams, and you can't mass something greater than 100 grams on our electronic balances. So if you want to be quick about this, you could use the little electronic balance that I have stored in the same place as the triple beams. So get your mass and record that in your data table. Now, the next step is to heat up those strips of metal. So what you want to do is you want to get about 100 milliliters of water in a beaker from the tap. And then you're going to add your strips. And then you're going to heat the whole thing to boiling. Now, things will start bubbling before they're actually boiling, so you want to make sure that your water has been bubbling for a minute or two before, and is thoroughly boiling before you assume that it's boiling. Once you start to see heavy bubbling and lots of steam being given off, then you can take your thermometer and hold it in like so. So it's not touching the bottom or the sides, and you're just going to hold it there for a little while until it stops going up. And hopefully it should read around 100 degrees Celsius, but it won't necessarily be exactly 100 degrees Celsius. It'll be close, because different thermometers have different amounts of natural built-in error. So you want to record exactly what it says, not what you think it's going to say. Also, boiling point does change slightly with atmospheric pressure, so depending when you're doing this, that could change. So again, don't assume it's 100 degrees Celsius, and make sure you read out as many places as you can on the thermometer, so you should be able to read between the lines and get a decimal place out of this. So after you get that temperature, what you're going to do is you're going to take your tongs and you're going to remove the metal pieces. But before you do that, you have to be prepared. So while your water is boiling, you're going to get your calorimeter ready. For our purposes, we're just going to use a styrofoam coffee cup as a calorimeter. It has a lid with 2 holes in it. One hole is for your stirring rod, one is for your thermometer. And you're going to get enough water in the bottom of your calorimeter to cover your metal strips. So ideally what you would get is somewhere around 25 or 30 milliliters. It should be about 1 inch deep, the water level in there. And what you want to do is you want to find the mass of that water. So what you're going to do is you're going to use your triple beam balance to find the mass of just the water in your styrofoam cup. So you're going to put the cup without the lid, without the stirrer, without the thermometer on the balance. And what you can do, if you know this technique, you can zero out the balance with the cup on it, which means you can just use the little adjustment knob under the pan to make the mass of that cup disappear, and then add the water, and then you can rebalance it, and that'll tell you the weight of just the water. Alternatively, you could get the mass of the cup and then just subtract it from the mass of the cup and the water together. Doesn't matter how you do it, as long as you know the mass of just your water. Don't make the mistake of adding in the mass of the cup as well. Record the mass of the water in your data table, and then the next thing you want to do is measure the temperature of the water. You want to give it a minute or two to get the temperature, because when it first comes out of the tap, it's actually colder than the room, and that water's going to warm up on you, and you don't want it to warm up you don't want the temperature to change until you're ready for it to change. So give it a second or two, give it a minute or two before you actually get the temperature of that water. You're going to record that information as well. And then when your water in your beaker over here gets to the boiling point, you're going to remove with the tongs the metal strips and transfer them to your calorimeter. As soon as you do that, you're going to immediately put the thermometer and the thermometer back in with the cap, and the temperature is going to rise really quickly. Pay attention, because you want to record the highest temperature that that thermometer reaches. Because what you're trying to find out is how much energy, heat energy, is transferred from the metal to the water. The only way to know that is to figure out how much the temperature rises from what it was at the beginning to what it is after the metal is finished transferring its energy. So you want to pay attention, watch for the moment when you reach the maximum temperature. Keep that in mind. Okay, so you're going to record the highest temperature that you see. After you do that, you should have all the information you need to do the calculations that the lab sheets ask you to do. Now, this is a new formula for you, and it has lots of weird symbols and things, so you may need some help and guidance filling in the data. I've tried to give you as many hints as I can in the instructions, but if you want to be walked through the process, you can watch the next tutorial, which explains to you how to find the specific heat from having done this. Remember, you're going to want to do this at least twice. If you have a chance, you can do it a third time. There's room on your data table for you to do a third trial. It's not written in there, but you'll notice there's room over on the right-hand side of the margin if you have time. See you in the next tutorial.